Hello everyone. So in this video we're just going to look at example of curl. Okay, so if you still recall, curl of f is actually given by our nabla or our gradient cross f bar, right? I'll just write the formula down. This is going to be quite a simple and easy refresher for you. So ijk, so remember our nabla or our gradient actually is given by the partial derivative of d over dx, d over dy, and d over dz. All right, and what should be our last one? Just going to drag this down here, and the last one here is going to be my fx, fy, fz. So see to that this fx, fy, fz is literally given by my f bar here, which is the vector field. So this will be the coefficient for the x, y, and z accordingly. Okay, so let's see. For example, if we have an f bar given by negative of yi plus xj, and they ask us to find the curl of f. Okay, so see to that we are going to use exactly what we have in the formula. We have I, we have J, we have K. First the D over dx, second the D over dy, third the D over dz. Alright, and what we put in over here, that literally depends on the coefficient that we have. Alright, for the I part. So this is actually my fx. Alright, this is actually my fx, and this is actually my fy. So sometimes when questions like this come about and you see this in negative y, what happens is that sometimes we have the tendency to just park this in y. So just make sure that we actually look at it according to the I, j, and k equivalent. Okay, so in this case, this is the x, this is the coefficient for my fy, so I'm just going to put it as here. I don't have anything in terms of k, so it will be 0 then. And once you have got this, everything is pretty good already. All we have to do is just perform the cross product. Okay, so for the cross product, we'll start with the I. So I'm going to sort of imagine that you're covering the row and column in which your I resides. So that leaves us with this one. So it will basically be a d over dy of 0 minus d over dz of x I, right? And then minus d over dx of, now I'm looking at it in terms of j, right? So this is my j part. So what we'll do is that we cover this row and column, and then that leaves us with d over dx of 0. So I'm going to write this down as 0, and then I have d over dz of negative y minus d over dz of negative y plus. So just remember this part here. If this is plus, the operator here should be a minus. Okay, and then for the k part, basically I'll cover this. That leaves us with these 4 bits here. So I'll have d of dx of x minus d over dy of negative y. Alright, so once we have performed this, then we can just differentiate it accordingly. So this itself will give me 0. D over dx dz of x is still 0. So literally it gives us 0i, right? And I have minus. I'll still have this as 0, right? And for this one, 0 as well, because I don't differentiate anything with respect to z. Again, so this is just 0j. So I'm just going to write it as this. For the last part here, d over dx of x, if you perform a partial derivative of x, it gives us 1, right? 1. And this one, partial derivative of y, negative y here, will give us negative 1, right? So if I have negative 1 here, this is negative 1. So this is negative. This minus here comes from this sign here. So this gives me negative 1. So over here, this is a K here. All right. So in the end, what we have is literally just 2K. So that's it. That's what we have for curl. All right. Simple and easy, more like a refresher for you. So I hope that you're all ready and fired up to do more questions on this. All right. Happy studying.